Hello, good morning everyone. My name is Shirjan and today I'm gonna give a presentation on magnetic circuits. And entering to the topic, introduction to magnetic circuits. Magnetic circuits are electrical analogous to electrical circuits, but they deal with magnetic flux instead of electrical current. They consist of magnetic materials and that guide and contain the magnetic field. Understanding magnetic circuits is essential for designing transformers, inductors, and electrical motors. These magnetic circuits channel the magnetic flux instead of the electric flux or electric current which generally passed by the wires itself. This consists of magnetic materials. These are made by magnetic materials which contain the magnetic field. These are not used to channel electricity, but instead used to channel the magnetic flux or magnetic energy. This understanding the circuits is essential for designing different sorts of circuits, such as transformers, inductors, and electrical motors. Fundamental concepts include magnetic circuits are based on concept of magnetic flux, which is total magnetic field passing through a surface. The unit of magnetic flux is Weber, WB, and is a measurement of quantity of magnetism. Magnetic field strength is denoted by H, while magnetic flux density is denoted by B. So these are some concepts which are important in learning about the ins of magnetic products, magnetic prospects, and the unit of magnetic flux is B, with the Weber, which is WB for short. Uh, and the key components of magnetic circuits. Core materials such as iron or ferrite, which are used to guide magnetic flux effectively. Air gaps in magnetic circuit can significantly affect its performance and efficiency. Windings or coils are used to create magnetic field and electric current flows to them. Core materials such as electric or iron or ferrite. Ferrite means a submetal of iron. These are magnetic materials which they are used to guide magnetic flux more effectively. Air gaps in magnetic circuit can significantly affect its performance. They should be completely closed and solid to improve its efficiency. Windings or coils are used to create magnetic field when electric current flows to them. Ohm's law for magnetic circuits. The magnetic equivalence of Ohm's law states that magnetomotive force is equals to product of magnetic field and strength of length of magnetic path. So the magnetic equivalent law of Ohm's law tells that the magnetomotive force is equals to the product of magnetic strength and magnetic path. The product of magnetic path gives us a magnetomotive force, which is the magnetic equivalent for Ohm's law. And this expression can be said, we can represent it as MMF is equals to H into Y, where MMF is equal to magnetomotive force, H is equals to magnetic field strength, and I is equals to length of L, not this L. L is equals to length of magnetic part. The magnetic flux pi is related to magnetomotive force with the formula of pi is equals to MMF by Rm, where Rm is a magnetic reluctance. Explore the topic of magnetic reluctance. Magnetic reluctance is the opposition that a material presents to the establishment of magnetic flux. It is analogous to electric resistance and depends on material's permeability and geometry of the magnetic circuit. High reluctance materials can hinder magnetic flux flow, while low reluctance materials facilitate it. The magnetic reluctance is a term similar to electrical resistance, like if current is not able to flow through the uh, medium itself, it may be called as electrical resistance. Same case with the magnetic reluctance. If a material is not able to harbor magnetic force or able to channel it, unable to channel it, is called magnetic reluctance. Uh, is generally a opposition which in a material which is opposite to magnetic flux, which doesn't able to let it, make it flow. High reluctance materials hinder magnetic flow, while low reluctance materials channel it. Magnetic permeability. Magnetic permeability is a measure of how easily a material can become magnetized and conduct magnetic lines of force. It is denoted symbol by the symbol nu and also varies significantly among different materials. High permeability materials like soft iron commonly used in magnetic circuits to enhance performance. Magnetic permeability is similar to conductance in electrical circuits as magnetic permeability is able to help show us how easily a material can conduct a magnetic flux. It is denoted by the symbol nu. It is also and varies significantly about different materials, and there is a difference in different sorts of magnetic materials itself. The magnetic permeability among them. High permeability materials like softer and commonly used in magnetic circuits to enhance performance. Series and parallel magnetic circuits. Similar to electrical circuits, there are also magnetic circuits, there are also arranged series and parallel combinations. In these circuits, the total reluctance is sum of individual reluctances, leading to the lower total flux. In parallel circuits, the lower total The total magnetic flux is the sum of fluxes through each path, which increase overall efficiency. Coming to the applications of magnetic circuits are crucial in designing of transformers which transfer electrical energy between circuits through various magnetic fields. Inductors utilize magnetic circuits to store energy in a magnetic field which current flows through them and current flows through them. Electric motors rely on magnetic circuits to convert electrical energy into mechanical energy efficiently. These magnetic circuits are used in designing of transformers, which harbor large amounts of electrical energy, and to channel the magnetic energy using these magnetic circuits. The inductors utilize magnetic circuits to store energy in a magnetic field. When current flows through inductors, they use the magnetic circuits to store energy in a magnetic field instead of electrical field. Uh, and yeah, electrical motors also rely on these magnetic circuits to convert electrical energy to mechanical energy more easily. Then by relying on only a single circuit, use multiple circuits uh, to convert energy into mechanical energy. Yeah, magnetic circuit design considerations. Designers must consider core material permeability and geometry of magnetic field path to optimize performance. And air gaps should be minimized to reduce reluctance and improve efficiency. The number of turns of coil affects the magnetomotive force and must be calculated carefully by the output. Designers must consider core materials permeability. So permeability is an important aspect. So it should be considered once in a while to understand the geometry of magnetic path and to optimize for accordingly to our users by understanding the permeability to understand to increase the performance rate of performance. Air gaps should be prevented and should not be present to reduce reluctance and also improve efficiency. The number of turns turns in the coil affect the magnetomotive force. Uh, so they must be calculated carefully for desired output for the output which we want. And losses in magnetic circuits. Various losses occur in magnetic circuits, including hysteresis loss and eddy current loss. Hysteresis is losses caused by lag in demagnetization or like the loss of magnetic molecules in the materials if they are magnetized and demagnetized. The eddy current loss results from induced currents in conductive materials leading to energy dissipation and heat. Oh, so yeah, when currents are inducted, eddy current means losses results in conductive materials, which may lead to energy dissipation in the form of heat. And yeah, coming to measuring magnetic circuit parameters. Magnetic circuit parameters measures using specialized equipment like Gauss meters or permeameters. Understanding these measurements is crucial for verifying the design and performance of magnetic components. Regular testing helps in maintaining the efficiency and reliability of magnetic systems. And yeah, magnetic circuit parameters are measured using specialized equipment, and there are many equipment is used to calculate these magnetic circuits and how and different parameter they calculate the parameters at which they are working, such as the magnetic field and the conducting the reactance, the magnetomotive force, etc., can be calculated by Gauss meters and the permeameters. Understanding these measurements is crucial for verifying the design and performance of magnetic components. By understanding these measurements, you can also calculate desired output, the output you want, and by calculating them, you can also able to reach the desired output you want and you want to reach. Uh, Regular testing may help us calculate the result approximately and accurately. Or also may also help us maintaining the efficiency and also reliability of magnetic management systems. Yep, coming to the conclusion, magnetic circuits play a vital role in many electronical devices systems, such as influencing their efficiency and functionality. A thorough understanding of magnetic principles enables better design and optimization of the systems. Ongoing research and development continue to enhance our knowledge and application of magnetic circuits. The presentation provides a comprehensive overview of magnetic circuits, covering fundamental concepts, components, applications, considerations for design and measurement. Yeah, these circuits are is a plays a vital important role in electrical devices and electronics. By understanding them, you can also devise many other technologies and also may influence many other technologies. There's a much is done on them to integrate them into further into our life and using this is used in these are in different concepts over entire lives, and there are many things which they are used in. Uh, if you have a decent experience among magnetic systems, you can also use them to optimize and also betterly design these magnetic systems. Uh, yeah, there are many more sessions being done to make sure they are more morely integrated into your life and also make sure the efficiency is improved. This presentation, the thing I have done, I hope it provides a lot of overview over all this and covers all the topics. And yeah, it may also consider all the development application for design and measurement. And yeah, thank you for listening to the presentation.